All right, I'm gonna get started because this timer is sort of counting down already. My name is Alexander Tarlinder. Actually, I'm born Tarnowski, so I actually understand Polish, but I haven't been living here for a while, so I'm actually a guest, and I'm very happy to come here. My talk will be about developer testing. It's a concept which I have kind of put words on. The majority of the people in here are doing something, either they're doing developer testing or they're doing something akin to developer testing, but I will give a framework for that. So my main goal with this talk is actually, if you're not doing developer testing, or if you're doing parts of developer testing, I want you to bring whatever you take with you home and just do more of it. And to sort of make you do more of it, I need to sort of tell you what developer testing is. So I will describe developer testing. And actually, I can just describe it in a sentence. Developer testing is the systematic and intentional use of testing tools and techniques while developing. And we will see what that means, why it's kind of important to do this intentionally and systematically. There will be some theory, some vocabulary, because I want you to either learn something here today or just confirm that you know everything. And that's also a good feeling, you know. If you go to a talk and you leave the room saying, hey, I know all of this. So I'll be glad if you do that too. No worries. There are discussions, if you're on agile teams, which I kind of assume you are, there are discussions about who does what and when and stuff like that, especially if you've got testers on board. So I will sort of help you and draw the line of responsibility. And finally, as I said, some theory. A few words about me then. I've written a book on developer testing. So I guess that's why I'm kind of promoting the term. There is a URL called developertesting.com or org. You do not want to go there. You want to go to developertesting.rocks because that's the correct one. The other two are sort of part of my online empire. They are not very beautiful, but there's some more theory and stuff on that. I'm here primarily as a developer. I'm one of those people who started coding on a Commodore 64. And I did have a break from the Commodore 64 to the PC because there were great games on the Commodore 64 and there were great games on Nintendo. So I can't claim having coded for my entire life, but for the bigger part of it. Currently, I'm doing something as unexciting or exciting, depends on sort of your view on this, as being a CTO, so I don't get to code all that much, but I get to have opinions on stuff, and that's fantastic. And not only do I get to have opinions, I get to have some power also. So recommended, become a CTO, it's fun. I've been doing Java for a couple of years, like since '99, and a bunch of other languages. Whatever, time goes on. So why would you really care about the stuff that I'm going to tell you? Well, there are three drivers, three like pillars of why you would care. And if you have had the privilege of being on a project around somewhere the late 90s or the early 20s, you most likely haven't really seen a waterfall projects because nobody has seen a proper waterfall project, I would almost claim, but you have seen something sequential. There has been, the project has had a long implementation phase in the order of magnitude of months or even years if you were unlucky. And you know, this is the classic strawman project where you would code and test. And well, it took a long time. What's been happening for the last 20 years almost is that we've had the introduction of agile development in more systematic ways. And we have seen that these methods have, the big value that I see in them is that they have pushed the point of convergence. They have introduced more and more opportunities to converge. And by converging, I mean that at some point in time, you need to get your shit done. You need to have it working. Scrum gives us the notion of an iteration, which is between 1 and 3 weeks. Practically, people do 2 weeks, right? So every second week, you need to converge. You need to have a working demo. You need to have something that's potentially shippable. Kanban, if you do Kanban and you're not cheating in Kanban, you will converge even more frequently. You will converge on a daily basis because you do pick your task, you do your task, and you're done, and you deliver. If you do proper continuous delivery, you will obviously be converging even multiple times a day because you will push your changes to production multiple times a day, which means that everything needs to be working. So the big takeaway is things are happening faster. And as they are happening faster, this of course gives us the regression testing challenge. And especially if you are a tester, you are worried about this, because it basically means that as you're adding feature to your product, you will not have time to test them manually or basically to submit them to any kind of testing process. So there needs to be something else, like some kind of degree of automation. So that's one driver for developer testing. Another driver is the fact that it's only developers who are able to actually create quality code. And this is, again, I kind of hang around with the tester community a lot, and these discussions have been going on for the last decade. But we've seen, I've picked like a bunch of quotes from smart people, like test first development and courage is Kent Beck's ways of sort of telling you that you need to be courageous, you need to have stuff in place to deliver frequently and sort of keep going all the way, all the time. Automate everything would come from continuous delivery, the guys who wrote that book. Potential shippable product increment is from Scrum. QA should find nothing is Uncle Bob's take on this. Build quality in is the lean approach, the Poppendix. And testing to support development comes from agile testing, the agile testing quadrants. So that's just a way of saying that smart people with beards and gray hair saying that it's us developers who need to build quality in testing, can sort of show you the absence of quality, but it can't really fix it. Last but not least, we actually have harder problems to solve. Now, I've been in this field for a while, and repeatedly I've sort of come to companies where they have had problems with, like, we can't make unit testing work, or our end-to-end tests are flaky, or whatever. The thing is now that, especially for the last years, we have harder problems than that, and we need to have that baseline covered. So as some examples, for example, there are numerous horror stories about, like high-frequency trading algorithms, or just software calling software without really human interaction, software bombarding our APIs at high speeds, making decisions. And the conclusion is basically that our software no longer has human users. So there's a machine calling our stuff, breaking our stuff with very irregular patterns, and we need to be able to deal with that. Integrations are always an issue, and in my little company, it's a small company, but our little team, our little company needs to deal with 10, 15 integrations with external partners, which are apps, which are email stuff, analytics, whatever. And we need to make sure that these integrations work, that our partners can consume our data and that we can consume our partners' data. So even a small company, we are really a small company, we need to make that work. I cannot even fathom what AI will do to all of this. Throw some neural networks at high speed stuff, bombarding our APIs. I don't even dare to sort of think what that will do. And obviously there are things I haven't thought of. Now, smarter people than me have said, okay, these are real problems. What we need to do is actually, we need to reverse the classic testing pyramid to take this into account, because the risks are no longer at the unit level, the risks will be at the system API integration level. Now, that's a bit drastic, but there is a grain of truth in this. So this is the third driver. We need to be handling those problems and not the fundamental developer testing problems. So without further ado, after this long intro, I will sort of give you the landscape of developer testing. And starting out, whatever we do, we cannot get away from the fundamentals of unit testing. Now, this is Mike Cohn's test automation pyramid. It can be, I'm kind of assuming that everybody's seen this. It can be drawn in this manner as well. You can add your relevant layers. You can sort of not do that if you don't want to, but the fact is still that it's got some properties. And one property is that stuff higher level, I call these higher level tests, stuff happening at the top of the pyramid will be taking longer time. Even though you sort of design these things properly, you don't have any artificial delays, stuff will be taking longer time. It will be more costly to develop, because here I am talking about tests which require an infrastructure, whereas a unit test is only, you know, it's. I'm thinking of a unit test as something that's got 5 to 10 lines of code and it's really easy and simple. Whereas these things, if you have a sort of complex domain, you will also have a complex test infrastructure. That is fine. You can have a good architecture for it. You can have proper design. You can apply clean code principles to it. Whatever. It's just going to be bigger. That's it, and it's going to cost more to develop in that thing. However, what we will see also is that the higher we move in this testing pyramid, the less information it's going to give us. The archetypical case is the like WebDriver-based test, which will fail. Something will not be working on the page, and it's really hard to get like a proper information from that test. It's going to tell you something's failed, but it's not going to tell you what. So what I'm saying is that we're still going to be doing unit tests for a while, and personally I think it's really important to nail the basics of unit tests, and that's why unit tests are indeed the basics of developer testing as well. And here I will throw in some theory about just some stuff that's worth know about unit tests. So this is really a recap. I really hope that this is nothing new. The reason why I'm bringing this up, actually I wouldn't want to include this slide in the year 2018. Again, we need to be solving harder problems. The reason why I'm including this slide is that I occasionally go to customers and clients and they will say, well, we've got unit tests, okay, great. We run them manually, or we can only run them in this certain environment and stuff like that. So there is still sort of a struggle sometimes, or a conflict in regards to what constitutes a unit test. So this is a definition, and there are actually shades of gray here, but this is the definition I'm using. And okay, fully automated, obviously you run it through your in your build. Self-verifying means that it's got assertions or verifies. Idempotent means that you can run it over and over again. Runs in isolation, it means that you can run them in any order, with any degree of parallelism, whatever. And the fast is sort of the hard one, but well, fast is fast. If you've got slow tests, they're obviously not fast. We can sort of dive into that afterwards. So there are 3 things I sort of want everybody to know about unit tests. And the first thing is how you name them. I'm just curious, just to get some interaction. How many of you are using a deliberate naming scheme for your unit tests? Cool, great. So then the next question is it one of those, or is it something else? So there are actually numerous naming schemes for unit tests, more closer to 10 different schemes, but these are the important ones I want you to sort of have seen. The first one comes actually from the like .NET world, which is, it comes from Roy Oshrove, and it does. I don't know whether you remember, I actually don't know whether these conventions are used. There used to be Java coding conventions published in somewhere around 97, 98, which were fantastic. However, they wouldn't allow you to have underscore in method names. Nevertheless, I usually I tend to break this rule of the convention. But what this says basically is all of these, in fact, all of these say that they emphasize two things. Whatever naming scheme you pick, it needs to do two things for you. It needs to tell you what is specific about the test and what is the expected outcome. These are the two useful properties of a naming scheme for unit tests. So that one does this by really saying it's a state under test expected behavior. Now, unit of work is a bit hazy, so let's not spend too much time on that. I think it's perfectly safe to omit the unit of work if it's kind of obvious. If it's not, then by all means include it. The second naming style comes from Dan North, BDD, and it's kind of been included in JBehave. There is criticism around this style, which say that saying that something should do something is not strong enough. What if it doesn't, right? Saying you should brush your teeth doesn't really imply that I will brush my teeth. So that's sort of the criticism here. My favorite scheme, which is really not really expressed anyway, is just a definitive statement about a property of the program. So just saying straight out what's going to happen. That's my favorite statement. Now the thing is this, these things will depend on your context. And it's not as simple as they will depend on the kind of system, but they will depend on the kind of like module or the kind of test you're writing. So in my opinion, it's perfectly valid to alternate between those naming schemes as long as you're doing it deliberately. Probably you don't want to mix and match all of them in one single file. That would obviously be very confusing. But feel free to sort of, if your mock tests, your interaction tests are better off with one of those schemes, feel free to switch around. The other thing you need to know about unit tests is structure. And again, arrange, act, assert, given, when, then, whatever. It's got multiple names. What's important here is not really the names of stuff here, but for good unit tests, what cannot happen for unit tests is that you start going back and forth between the act and assert stage. That's lethal, because that means that your unit test is getting long. It's getting long. You're setting something up, you're executing stuff, and then you're verifying something, and in the next minute you're kind of not happy, and you're doing something else and verifying again. Now, that is super acceptable behavior for end-to-end tests, which take a long time to run, and they will be complicated. They will be executing flows, so perfectly fine to do that. Just don't do it in unit tests. So this is the other thing you need to know about unit test. The third thing is actually this. There are, I don't know exactly where this was born and coined by whom, but there has been a phrase saying that a unit test should end with one assertion. And it's a fantastic statement if you sort of can adhere to it. But that is not the intention. Of course, if you can have your unit tests end with a single assertion, that's fantastic because it either passes or fails, but that's not the underlying statement here. You need to make a distinction between semantic and syntactic assertions. And I'm showing you kind of a trivial example here. The semantic concept here is splitting strings. Super trivial programming 101, splitting this string. And obviously, it's one concept. And obviously, we can express it using either 3 asserts or 1 assert. And the thing is this is trivial. However, think of this. We do have matchers, right? a matcher can basically bundle together up to 20 assertions in a predicate, and it will still be only one assert that. So you will have 20 conditions or something in one assert that. Your test will end with one assertion, but it will probably not be a very good test because you've stuck all the complicated stuff into your matcher. And obviously you're not testing one semantic concept, you're testing multiple semantic concepts with one syntactic construct. So that's the thing I sort of want you to bring with you. Semantic versus syntactic assertions. So this, I kind of hope, was a little of a repetition. But what really gets people is this. Okay, so we know our unit testing frameworks. We know our Spock or JUnit or whatever we're using. But then comes the question, how many tests do we need to write? And that question carries kind of an implicit question, which is, what do we need to test? And this is sort of the essence of developer testing, is marrying together testing and development techniques. And the first technique we'll be using is equivalence partitioning. So if we've got these pseudo-structures, there's obviously 4 cases here. Obviously, for boxes, you can stick stuff into. And just to give you an example of this, let's say we're doing something related to adult people. I will be building up on this example. It's a numerical example, so it's kind of trivial, but that's not the point. We're doing something with a numerical example, adult people. So in deciding on whatever we are testing here, in deciding on what the number of tests we need, is obviously we need to do stuff with various ages. So sorry for kind of saying that people are not allowed to be older than 120 years. Please forgive me about that. But we need to look at all the age intervals here. So this will kind of give us a clue. And these are called equivalence classes because it doesn't really matter from the perspective of this particular program, this particular context, this particular functionality. It doesn't really matter whether you're 23 or 43 years old. These values are equivalent. Now the trick is that you need to sort of make a mental effort to determine what is equivalent. It's very easy to do this in a numeric problem like this. If your equivalence classes are more like sets or just a bunch of values, you need to do some thinking, and that's the kind of thinking a classically trained tester would do. You need to do the kind of thinking, what is equivalent? So obviously in this case, these things are equivalents, and we also have invalid partitions. And we need to be looking at those invalid partitions as well. Depending on your context, you may treat them as 1 or 2 partitions, but this will give you a clue about, I need to have at least a test that targets this partition. Now, the interesting thing is that all interesting off-by-1 errors or bugs tend to cluster around edges of partitions, which testers already know, which is why they have something called boundary value analysis. Boundary value analysis tells us that we need to, if we're testing something like this, where there are interesting stuff happening at the boundaries, we need to add cases at the edges of the boundaries. So this sort of gives us a very clear answer to how many tests would I need and what do I need to stick into my unit tests. This is one way of looking at this. Another mechanical sort of testing technique is using decision tables. And this is super basic, super fundamental. It's called fundamental testing techniques because it's very, very basic. What's important about this, there are 2 things which are important about this. So there's nothing complicated about this. It's dead obvious. I can sort of see your eyes. Well, it's dead obvious. But 2 things need to happen here. First, we need to develop the ability to incorporate this into our planning meetings, talk around tables, talk around concrete examples, because all this BDD, ATDD, spec by example, starts with concrete examples and tables. Often it's tables, not always, but it's often tables. So we, as members of agile teams, we sort of need to develop that ability to start sketching on the board or on a paper, thinking tables. Second of all, we will see that these tables will sort of have an impact on how we will write our unit tests, and I will be coming back to that. There is another testing technique, still fundamental testing technique, which is called state transition testing, and that's a visual technique. And okay, you can read it, fantastic. So there is a class of problems which is naturally modeled as state machines, like parsers and stuff like that. Now, the interesting thing is this thing, how many of you have actually owned something like this? Okay, good. So I've owned 2, and I will tell you why that is significant. This diagram is a state diagram, sort of depicting the various transitions that can happen if you press the button on these things. However, one of my Walkmans was able to do this transition between playing and rewinding. You would press the play button, click, and then if you didn't sort of, or you wanted to hear Roxette again, which was what I wanted to do, you press rewind and you could press play again. The other one actually had some kind of locking mechanism where this was not possible. You had to press the stop button, then rewind, then start listening to Joyride. And this is exactly the purpose of this technique, to bring out, to visually sort of create associations and bring out the discussions. Do you need to press the stop button or do you not to? And this also sort of translates kind of mechanically into a number of test cases, because we can kind of count the transitions. We have the state, we have the transitions, we can just count stuff and we will know how many test cases we need. So all these are called fundamental testing techniques, and this is double geek humor. They answer the questions. These things answer the questions. How many tests do we need? If you're parsing binary, if you're good at parsing binary, you will see that this parses into 42. So this is double layer geek humor. Okay, so we've got unit testing and we've got fundamental testing techniques. The next thing that happens is that, okay, Alexander, that is great. You've got your fundamental testing techniques, but my system is special. There is no way you will be able to apply your fancy stuff here because my system is special. My business rules are unique. My problem domain is like no other problem domain. So, yeah, good. Thank you. I needed that boost of energy. I need some recognition here. Am I the only one who's been exposed to this? Maybe. Okay, so 2 of us in here have been exposed to this. And to talk about, what's actually testable and non-testable, we need to have a vocabulary around that, because testability is very emotional. It's also, it's also the card you would be playing if you don't want to attack your legacy system. You would say, I can't test this untestable system. So this is testability. Testability is super mechanical. It's three things: observability, controllability, and smallness. Controllability is the ability to put something in a certain state, whatever that is. Do we have the knobs and levers to put that piece of code into a certain state? And if you've worked with legacy systems, which I kind of assume you have, you would see that it's not always easy, because there will be a singleton, there will be a database, there will be a queue, and there will be a mess around this, and there is no way to put that into a certain state. So that's bad controllability. Observability is sort of the other side of this. It's to be able to peek into what have we achieved. Again, with some singletons, queues, and databases nicely intertwined into spaghetti, it's kind of hard to see what you have actually achieved by executing certain code. Smallness is also important because smallness means that whatever you're having a little of it, and I will explain what a little is. So smallness comes in two sizes. Smallness comes from few features, which means you need to have active product ownership. You need to have whatever customer on site or product owner you're having, that person needs to understand that code is a liability, it's not an asset. So that person needs to kind of be interested in keeping the number of features down, to keep the amount of code down. And as a team, you need to do some active pruning, kill code, which is not used. And that happens far too seldom. In terms of the footprint on the code base, smallness is characterized by singularity, which means that you are not duplicating code. So that's kind of simple. Level of abstraction means choosing the right language or framework for the problem. So let's say you're having a Node application where you are starting your Express server, and you're returning hello world. That kind of requires 5, 6, 7 lines of code. Had you done this in C, you would start implementing your socket API, you would start doing a fork, you're receiving bytes through a socket, you're doing a fork. That's obviously not the right level of abstraction for returning a hello world through an API. When I speak about efficiency means knowledge in patterns, idioms, and general sort of ways of working. And by that I mean that that there is it's kind of related to reuse. There is a construct or a library or a construct plus library that sort of solves your problem. It's basically about not reinventing the wheel. So if you've got these three covered, you can reason about testability. You can really say that line of code or that system, that component exhibits poor testability because of bad it's being too big, but the opposite of smallness, it's not being observable. And that means that it's sort of applicable at all levels. From a single line of code, you can mess up a single line of code to entire systems. And that means that this will influence both the craft of writing code and the design, your design and architecture. So this is kind of important. I've been speaking about legacy code, and legacy code is in fact the primary reason for not doing developer testing or any kind of testing that requires developers to do something about this. And legacy code, now fortunately this is a Java heavy conference, so I can get very mechanical here. When we attack legacy code, there are dependency breaking patterns which are super standardized throughout the Java world, and I will kind of fast forward through them. But the point of me showing them is that this is a box, this is just a skill set that you need to have. You need to be able to say, okay, I'm good at dependency breaking. So I'm just going to give you some very quick examples. So stuff is kind of getting bad already at this level. It's from a testability point of view, it's kind of game over here already. So you wouldn't really want this to happen. Okay, it's a good picture. Yeah, so action. Yeah, okay. So, and there's a number of things we can do. I'm just going to throw these snippets of code at you. So this is what you would probably not do, but you can do this. You can sort of have your bad object giving you your indirect input or whatever, you can have it as a static and you can start replacing it. More classical things are constructor injection, right? This is standard dependency management. A constructor injection, setter injection, had this been C#, you would be using property injection. If you don't want to be invasive, you can obviously just override a factory method. And so this is very mechanical. You have legacy code, you apply this stuff, and you have eventually cleaned up all your dependencies. Very, very mechanical. But I'm just saying that, and this kind of varies from language to language. I said that in C# you would be using property injection. In C you would probably do something with a linker, but it's mechanic, and that's the basis of dependency breaking. Now, if you're able to break dependencies or not have dependencies, let's talk about mocks. And this is my not so very favorite topic, because still, to many people, everything is a mock. And that's also a core competency of developer testing, understanding that not everything is a mock. And this is important. I will tell you why in a minute. Why this is important is that if you overuse mock objects or mock, you will make everything into an interaction test. And interaction tests, by their nature, are more complicated because you need to sort of keep track of interactions. 2, they very, very easily start locking down your implementation. So it's the path to the dark side. You can tread it carefully. Not necessarily will you sort of slip over to dark side. I'm not saying that, but it's the step to the dark side is very, very small. So not everything is a mock. So knowing the different kinds of test doubles helps. And this is like a session in its own, but I just want to emphasize that mocks or mock objects are the ones that can fail your tests. And these are the ones, their primary purpose is to provide you with, their primary purpose is to verify indirect output and interactions. So obviously you need to know about indirect and direct input and output also, which I've kind of skipped. But that's what mock objects do, and they are the ones that fail your tests. A stub is very, very stupid and intelligent. A stub will return a value, and I'm kind of really making that distinction in my code, and many frameworks will not help you here. Many frameworks will want to create only mocks. Everything will be called mocks, but that distinction is very, very important because a stub, it can never fail your test. It will give you a value. Now, there's nothing magic about those things. You can create them, handcraft them. You do not need a mocking framework to do them. You can know about dummies. These are just values you don't care about in argument lists. Fakes is another kind of test double, which I have used like once in my life, and that's lightweight implementation of something. It's just good to know. What's interesting about spies is that if you're very academic, you will tinker and play with the distinction between a spy and a mock object. And if you really care, you also know that a mocking framework actually creates spies. The majority, not all of them, the majority of mocking frameworks will actually create spies and not mock objects. But you don't really care because you're using them like a mock object. So I'm just telling you, there is a distinction. We can play with them if we craft them by hand, but normally we don't care. So what I've shown you so far is sort of areas of competence, of stuff where you need to apply deliberate effort, deliberate knowledge to sort of be in. So we're almost home. I'll show you a few more. Now, I told you that you can apply your boundary value analysis and equivalence partitioning to to your problem domain, what's going to happen is this. This is what happens. And I'm just warning you here, this is not where you want to be, even though the naming scheme is correct. This is not where you want to end up. But this is what happens if you sort of start really picking up all the cases that you need. So where you need to be is obviously in another world in which this problem has been solved. You need to be in the domain of parameterized tests. And I'm just sort of making the connection here because some people will use parameterized tests as a cool feature of a framework, whereas it's actually quite mechanical. You will apply standard testing techniques, you will combine them with unit testing, and this is where you will end up, especially for numerical kind of problems. Now again, this is my age interval problem, but it does happen quite often. Numerical tests, parameterized tests translate from numerical tables directly into a test. And they are supported by pretty much every major framework. So just go ahead and do them if you're not already. We can sort of move one step further. We can move to theory tests. Parameterized tests are tables, tabular tests. Theory tests try to sort of be less verbose and more relaxed. And the way I usually explain theory tests is, again, I've got the same ages that I had on the last slide. They are sort of they are combining your different sets of input parameters automatically by the framework and generating all the test cases. This will be generated automatically. So had we had another set, we would just get a Cartesian product of this. So here the framework, we're starting to give it data points and it's going to inflate this for us. It's going to generate these tests for us. Obviously, not all cases that will be generated here will be valid, so they can be sort of assumed out. There is a method called assume in many frameworks. So you can sort of try this also. There is one more step, which I don't really cover with a slide, but if theory tests are not sufficient for you, you can go for generative testing. With generative testing, you will have a generator. You will have generators of values. You would have something saying, give me a number between 0 and 120, which was the age interval. You don't care what numbers you get. You specify how many you would get. And the computer, the framework would generate that for you. Now that obviously has the problem of verifying correct results, but that's also a solved problem. What I'm saying is that as you apply testing techniques, you have a range of opportunities to go from parameterized tests to theory tests to generative testing to sort of cover all the explosion of test cases. Developer testing wouldn't be complete if it didn't have a notion or opinion on test-driven development. I still occasionally meet people who say that test-driven development is more or less magic. So I will make this very, very not dramatic. Test-driven development is not magic. Test-driven development has nothing to do with testing. It's a design technique. You design your code by writing tests first. You obviously need to know about the red-green refactor cycle. That's cool. I mean, if you do test-driven development, you obviously need to know about that. What maybe some of you do not know are these patterns for going from red to green and test order. So I will spend a few minutes talking about them. So the patterns, TDD patterns, are faking, which is returning a value, a constant. You know, whenever you try test-driven development, in your first test, you will return some kind of hard-coded value. That's faking. Nothing in test-driven development says that you need to be stupid. If you know the obvious answer, just write the obvious implementation. That's allowed. That's okay. Nobody will kill you for it. Triangulation is about throwing multiple examples, writing tests, throwing multiple examples and hoping that you will tease out the problem. So that's triangulation. So these are patterns. You just need to apply them. There is a good order of tests in which to write tests when doing TDD. So that's kind of, obviously, we start by teasing out the API, we cover the happy path, we try variations of it, and we do negative testing last. Why is negative testing and error handling done last? Well, because it doesn't really help us to drive any design. So the object of test-driven development is to drive the design. Handling edge cases and negative cases doesn't really drive the design. It hardens our program, it makes it more stable, but it's not really helping. Higher level tests. Now, there is not a single book on this topic because it's too context dependent. Basically, as we're moving up in this pyramid of testing, stuff is happening, nasty stuff is happening, and these are kind of examples of higher level tests, what I consider to be higher level tests. When you start going through the UI, invoking other systems, if you do something in a transaction, you know, abstract transactional context, that Spring thing, these are all higher level tests. What we sort of need to acknowledge is that these tests will be different from our unit tests, and they have a different profile. Now, do take these numbers with a pinch of salt because they're kind of unscientific. I'm just telling you that higher level tests will be more complex, they will be less stable, they will have a harder time showing you what kind of errors there are. They will be less performant, and they will actually, they can't run everywhere. They will need a certain environment. And we need to design for that. That's all that I'm saying at this point, because this is a huge topic. And this concludes the sort of overview of developer testing. These are the core competencies you need to know to apply developer testing. Okay. So if we know all of this, what do we do with this? Okay, so we understand that there are boxes of competencies that we need to do. Then we need to kind of think of how we apply this. And these are like profiles of systems. These are profiles like systems. So imagine if you're doing an early greenfield stuff, everything is good, you haven't brought on any legacy. What you will be doing, you will obviously be test driving your code, you will be doing unit testing, you will probably not do any data-driven testing, not so much at least. And the same goes on for the different other profiles. I'm not saying that you will not be, for example, doing test-driven development in classic legacy. That's not what I'm saying. I'm just saying that you will be emphasizing other stuff in these things. So you will be using different core competencies depending on your system profile. And developer testing is a way of telling you which competencies, which theories, which stuff, what kind of stuff do I need to know to navigate in my in this particular profile. And with that, I kind of want to sum up and just say that we've seen 9 core competencies of developer testing. The important thing is to apply them systematically and intentionally, and that's why there are core competencies. That's why there is a nomenclature that you need to be aware of. And well, check it out, read up on this. There's a book. If I have time for question, I'm gladly to take one or two. Yes. I think.
So I will throw a stick into the ant nest. Okay, there is a kind of, in my opinion, false assumption that, for example, Java systems should be tested with JUnits. I totally disagree with such opinion, and I actually have a good experience with testing Java code with different languages, more expressive languages and frameworks. What is your opinion on that topic?
Could you give me an example?
Often we meet things, systems in general, that JUnit is used for everything. Unit testing, integration testing.
Okay, I get your question. Okay, so obviously, I don't think there's going to be a debate here, because as soon as you move to the system boundary, you're free to choose whatever tool you like, right? So there's my opinion is very nice. Go ahead, pick the proper tool, because JUnit will obviously be tied together with your unit tests, and if you're testing stuff from the outside, pick any tool you like. So no opinion, no debate. Okay. Aha, okay. Well, I'm sorry, no debate here. Okay, so thank you.